Hey there, welcome to this video 10-4, and we are going to talk about solving base E exponential equations in this video. Just a refresher, I want to remind you guys of the identity-based property, and that's what we tend to use a lot when we take the natural log of a exponential function that has a base E. Well, because they are inverses. I want to refresh your memory on this property, that log base B of B is just 1. Exponential base and a logarithmic of the same base they are inverses. So if I have the natural log, right, which is log base E of E, well, that's just 1. So the natural log of E is 1, and we're going to be using that idea in today's lesson. So how are we going to go ahead and solve base E exponential equations? Our first step, well, I guess before even step 1, is to isolate an exponential base. I need to have an exponential base by itself, and then I can go ahead and utilize the natural logarithm of each side. And we're specifically utilizing the natural logarithm because we're using base E exponential equations today. After that, we can use the power property to pool any powers that we might have inside logarithmic arguments. And then we will use algebra to go ahead and solve the equation. Lastly, state the solution. Okay, so again, reminder of the property of logarithms, that log base B of B is 1. Okay, so we're going to be using that idea today. Here's our very first example. Write this one down. They asked for the exact solution and the approximate solution rounded to 3 decimal places. So we're going to have to keep that in mind. I'm going to go ahead and isolate my exponential or my power expression. Okay, e to the 4x. I need that to be by itself, so I'm going to divide each side by 5. Giving me 2 is equal to e to the power of 4x. So I need to solve for x. I need to pull that exponent down, and how we do that is we take a logarithm of each side. Now, which logarithm are we going to use? Well, I'm specifically only going to use the natural log because I'm working with a base E, and that is going to help us out and further simplify. Okay? So this gives us the natural log of 2 is equal to 4x times the natural log of E. And remember, what did we say about the natural log of E earlier? That this is just 1. So really, here's our equation. Natural log of 2 is equal to 4x. Okay? How do we undo multiplication? We divide. So our solution is x is equal to 1/4 natural log of 2. Or you can go ahead and write it this way, natural log of 2 divided by 4. Be careful, note that this is completely different than the natural log of 1/2. That 4 does not divide into the argument. You must keep that argument the same. Okay, so we want a approximate solution as well. So I'm going to go ahead and say, okay, what's the natural log of 2 divided by 4? Looks like we get 0.173. 0.173. Okay, so there is your exact solution and your approximate solution. Here is example 2, which we're going to have to do a little bit more heavy lifting in this example to isolate our power expression, e to the power of x plus 2. I want to go ahead and this time I'm going to undo addition and subtraction first. So I'll add 8 to both sides, giving us -3e to the power of x plus 2. And anytime I rewrite that binomial exponent, I like to add the parentheses just because that's going to help me later on. And on the right side, we get -9. Okay. Still haven't isolated my power expression. Now I need to divide each side by -3. And we get e to the power of x plus 2 is equal to 3. Okay, power expression is isolated. Now I need to go ahead and take a logarithm of each side. Which logarithm am I going to use? The natural log, especially because I'm working with base e. It's going to simplify and make our lives a lot easier in solving this. So I can go ahead and bring down my power expression, x plus 2 times the natural log of e is equal to the natural log of 3. And the natural log of e, that's just 1. So really this becomes x plus 2 is equal to the natural logarithm of 3. Natural logarithm of 3. And now I'm going to solve for x by removing 2 from the left side. Okay, so we get our solution here. X is equal to the natural log of 3 minus 2. Do not add that negative 2 into the logarithm. Okay, it occurs on the outside. So let's go ahead and see what this is approximately. Menos dos, negative 0.901. Negative 0.901. Okay, so there is our exact and our approximate solution to that equation. Okay, I have some practice problems here for you. I'm going to go ahead and let you pause the video and give these ones a go. Okay, hopefully you tried this one. You want to divide each side by 6, which gives you 2.5. If you left it as 15 over 6, that's fine as well. Take the natural log of each side to give you negative 3x is equal to the natural log of 2.5, and then you divide by 3, and you get your answer. All right, here is a second practice problem. If you want to go ahead and pause the video and try this one. Okay, hopefully you pause the video. Remember on this one, you have to undo addition subtraction first, right? I can't divide first because then I have to divide that plus 5. So you subtract 5 on each side first, then you divide each side by 2. Take the natural log of each side, and then add 1. There you have it. Okay. Next, we are going to go ahead and get into some more complicated examples, and we're specifically going to look at exponential equations that have a trinomial structure. And it's very, very important that you remember how you would factor just a trinomial into 2 binomials. And just imagine if it was a regular quadratic, okay? And then from there, we will solve using the zero product property, and I'll give you an example. So here we're asked to solve this equation, and note that it is very, very different looking. But I want you to see the structure. I want you to think this. I want you to think x squared minus 5x plus 6 is equal to 0. So if you went ahead and factored this, this would be x minus 3, x minus 2 is equal to 0, right? I think, okay, what factors of positive 6 give me a negative 5, and that is negative 3, negative 2. And then I take the square root of my first term to give me my first term in my binomials, which is x, which also matches the linear term in my trinomial, right? So you can think of that this way. Another fact that might help you out is that e to the power of 2x is really e to the x squared, okay? So if you think of it that way, you know, that can kind of help you out. And I'll go ahead and rewrite it this way. Okay, so I'm going to go ahead and factor this trinomial like a regular binomial. I'll open up 2 parentheses, and I'm going to say, okay, what factors of 6, positive 6, give me negative 5? That would be a negative 3 and a negative 2. And I'm going to take the square root of my first term, which is e to the x. So I factored it. Now I can go ahead and I can apply the zero product property. Which just says I can, if both of these factors are equal, multiplying and equal to 0, then each of them can be 0. So e to the x minus 3 is equal to 0. E to the x minus 2 is equal to 0. I'll add 3 to each side. And I get e to the x is equal to 3. Okay, I want to solve for x, so I'm going to go ahead and take a natural log of each side. So when I do this, natural log, we get x times the natural log of e is equal to the natural log of 3. And remember, natural log of e is just 1. X is equal to natural log of 3. Okay, so there's one solution. Over here, I'm going to add 2 to each side. And we get e to the power of x is equal to 2. Again, I will take the natural log of each side. So I have x natural log of e is equal to natural log of 2. So x is equal to the natural log of 2. And both of these answers are solutions. We may run into domain issues if I get arguments of my logarithm that are not positive, non-positive. So if they're 0 or if they're negative, we got to throw them out because those aren't valid domains of logarithms. So they would be extraneous solutions. Okay. All right, let's go ahead and look at one more example. So a similar idea here, I have e to the power of 2x. Well, that's e to the power of x squared plus 4 times e to the x minus 5 equals 0. This is a trinomial structure, meaning I have 3 terms, and I want to go ahead and solve by factoring it into 2 binomials. So what factors of negative 5 add together to give me a positive 4? And that looks like it's going to be a positive 5 and a negative 1. Take the square root of the first term. That gives us e to the x plus 5 times e to the x minus 1 is equal to 0. We'll go ahead and use the zero product property. So e to the x plus 5 is equal to 0, or e to the x minus 1 is equal to 0. And we will solve. E to the x is equal to negative 5. Go ahead and take a natural log of each side, and I don't really like this. We have x natural log of e, which we know is 1. And you can kind of think that the natural log of e almost just disappears, that we get x is equal to whatever is on the right side. Natural log of negative 5. And that's a domain issue. So we're going to cross that out. Remember, domain of all logarithms is greater than 0. Can't even be 0. It's got to be greater than 0. Remember, you have an asymptote at 0. Okay, right side. I'll go ahead and add 1 to each side. And we get e to the x is equal to 1. I will take the natural log of each side. And we get x is equal to the natural log of 1. This is also an identity. The natural log of 1, that value is 0. So x equals 0. That is our answer. Okay? All right. I'm going to give you guys a shot on the factoring a trinomial structure. If you need to, look back at those previous examples so you can look and see how I factored this trinomial. Okay, think of it as a regular quadratic trinomial structure. All right, pause the video, give it a go. All right, hopefully you pause the video. Here is the solution, and really the factoring I think is the hardest part of these. This would be e to the x plus 2 times e to the x minus 6 equals 0. So if you have this, you can go ahead and solve each one by setting them equal to 0. You get e to the x equals negative 2. There's a domain issue there. You cannot take the natural log of negative 2. So we throw out that answer, and on the other side we have x is equal to the natural log of 6. Okay, here is another practice problem. Go ahead and factor this trinomial. Okay, and this example might have been a little bit more tricky for you with the factoring because you have a coefficient, a leading coefficient of 3. But the correct factorization would be 3 times e to the x minus 1 times e to the x minus 2. So if you go ahead and set those equal to 0 and solve, you come up with two solutions: natural log of 1/3 and natural log of 2. Okay, last example I have for you guys is a binomial structure. So same idea, solve the equation, give the exact solution and the approximate solution. I'm not sure actually up here if I gave the approximate solution. So we'll make sure we give the approximate solution for this. So a binomial, think of this again as a quadratic binomial. What if this was x squared minus 5x? And often you solve binomial expressions with a factorization utilizing the greatest common factor. So what's the greatest common factor? So again, e to the power of 2x is the same thing as e to the x squared. So I will rewrite that. And I'm going to take out what they have in common, which in this case is a e to the x term. So that leaves me with an e to the x minus 5 is equal to 0. I'll now use the zero product property. So e to the x is equal to 0, and e to the x minus 5 is equal to 0. We'll go ahead and take a natural log of each side. So natural log of e to the x is equal to natural log of 0. And again, we end up with this situation. X is equal to the natural log of 0. Well, again, this is a domain issue. I can't take the natural log of 0. So we're going to throw that answer out. And we'll solve the problem on the right-hand side. I'll add 5. So e to the x is equal to 5. I'll take the natural log of each side. And we get x is equal to natural log of 5. Which this time, I promise I won't skip out on that. Natural log of 5, 1.609. There you go. All right, that's solving a exponential equation with base e in a binomial structure. All right, last practice problem for you. Please pause the video, give this one a go, check your work. Can you do it on your own? All right, hopefully try this one. Again, if you factored correctly, you should end up with this equation, e to the x times 2 e to the x minus 1. So if you go ahead and solve, again, on your first solution is natural log of 0. There's a domain issue there. So we throw out that solution. And then the second solution yields natural log of 1/2. All right, that's going to do it for this video. We went ahead and solved exponential equations involving base e, both from a trinomial structure and a binomial structure. And I will see you next time. Be safe, be easy. Peace.